Physics, Newton's laws, P22I, apply Newton's second law. So we're discussing second law now in calculations relating forces, masses, and acceleration. So here we'll have, as the title states, we'll have a relationship between the force that pushing or pulling an object, how heavy that object is, so the force, the newtons, how heavy the object is, the kilograms, and how faster or slower we'll be able to make that object to move. And that means meters per square second. Let's look at this airplane. This airplane, when it's taking off, the thrust equals the air friction. So those two forces are equal. So the object is going to take off. It's going to move upwards because the lift is larger than the weight. Now, this diagram is not 100% accurate because the thrust, it is a little bit larger than the air friction when it's taking off. So that's why the object is not taking off like just upwards. It's going to take off in a diagonal. But for the sake of the formula, let's just say that the lift is larger than the weight. Newton's second law, which this is the basic form in which we're writing it, F equals ma. It's the law of unbalanced forces. That means it's the law of acceleration. There is an acceleration. So the object can be moving faster, acceleration, or slower for deceleration. If you need to put the law in a triangle, the force will go on the top of the triangle and mass and acceleration will go on the bottom. If I'm looking for mass, that's going to be force divided by acceleration. If I'm looking for acceleration, it's going to be force divided by mass. And if I'm looking for force, it's going to be mass times acceleration. Let's say the situation of a rocket. The rocket is going to go faster and faster because there is an overall force. That means the force that's pushing the rocket forward is larger than the air resistance, which means this rocket, which has a mass m, will be able to move forward with a certain acceleration a. So that means the force, the overall force, the resultant force that's pushing the mass of this body will give this rocket a certain acceleration. So this is called the unbalanced force. This is called the resultant force. In this situation, the rocket will be moving faster. Now, if we look at the formula, F equals ma, the more force, the larger the push or the pull on that specific object of the same. Let's say you see here on the diagram we have the same ball, the blue ball and the blue ball, they're exactly the same. So we assume they have the same mass. That means the larger force will push this ball forward, will pull the ball with a larger acceleration, because if you increase m and the m stays the same, a must be growing bigger. So if F is growing bigger, acceleration is also growing. Now, in this situation, you push the cart with a force, and the car will accelerate, or the cart will accelerate. Okay. Now, if you're adding more masses on the cart, and you're pushing it with the same force, now obviously this cart is heavier now and it won't be able to move as fast as previously. That means you get less acceleration. That's if you look at the formula, we just readjusted F equals ma. We're looking for a, which means m goes as a division under below a force. So if the force stays the same and the m is increasing, that means the acceleration of the object will decrease. And it's normal if you're kicking a light ball or a heavy ball with the same force, well, the light ball will be able to move faster. The same thing here. This cart is lighter. Well, with the same force, I'll be able to push this car faster. That means it will accelerate faster than when the car is becoming heavier. And this is the situation when I'm looking for acceleration. If we have we introduced another vocabulary term which is called inertia. Inertia is a measure of how difficult it is to change the speed and the velocity of the object. It is related to the mass of an object. So inertia is the mass of an object practically. So the mass of an object is always dependent on the force that's pushing that specific object and how fast do we want that object to move. That means the force divided by acceleration. And if we look at this situation, we have one book and then we have a stack of books. Now mass is defined as the ratio of force divided by acceleration. Now, it's always easier to move one book than a stack of books. Because for the same force, if you have one book, well, that book will be able to go with will be able to give that book a larger acceleration than if we have a stack of books for the same force. So this is the situation when we're looking for the mass of that specific object. So one book has less, we say that one book has less inertia than a stack of books because it is easier to move one book than a stack of books because it requires more force as the mass is larger. So the stack of books require more force to move as the mass is larger. The last example, this person is pushing a trolley. The trolley is empty or the trolley is filled with goods. When obviously, when the mass of the trolley is increasing for the same force, now we say that the person has the same force, it's going to be easier for the person to push faster the empty trolley than the heavy trolley.